Next method of image compression is LZW coding. So now here in Hoffman coding for decompression we have to send the table along. In LZW coding that's not at all needed. It is fully adaptive. We first of all build a dictionary only for the single word codes, and then after that it creates a mapping on its own. So it's used for GIF, TIFF, PDF, Unix compression, and so it was based on LZ78 algorithm. We will go through these steps once we see the overall working with an example once. So consider I want to encode the string AB, AB, ABA. Initially in the dictionary it is, now what are the unique characters? A equal to 1 and B equal to 2. This we should keep in mind. Now first of all, see my characters are AB, AB, ABA. This will be my character that I'm reading it. Okay, so this particular column is are all these characters. Now we have something known as W. Initially it is empty. WC is nothing but concatenation of these two, and so concatenation of this null and A gives me A. So WC is basically the concatenation of this. We should check if it is there in the dictionary. If it is there in the dictionary, we do not have to do anything. Is A in the dictionary? Yes, A in. We should check. So this C indicates all my characters that I'm reading. W, we will see what is it. WC is basically the concatenation of these two. We should check if it is there in the dictionary. If WC is in dictionary, yes, it is there. We don't have to do anything. Now, this value of WC becomes the next W. If WC is already in the dictionary, set W equal to WC. Okay. So now here W is equal to WC. Now for the next iteration, my W is nothing but this WC itself. The next character that I'm reading is B. Concatenation is AB. Is AB in the dictionary? No, it is not. Then in that case, here if it is not in the dictionary, three steps are to be done. The first step is whatever is the code for W, that has to be output. So here I'm telling A. That's the first step. The second step is AB should become a new entry. So now AB is equal to 3. This is the new entry that I get. And the last step is W is equal to C. So what is my C value? That becomes W. Now the next character that I'm reading is A, BA. Is it there in the dictionary? No. Again we repeat three steps. What are the three steps? First of all, output the code for W. Make BA as the new entry here. And the last step is whatever is my C value becomes W value. I'm reading AB. I'm reading the next character as B. As you can see, this B. I'm reading it. Concatenation is AB. Is it there in the dictionary? Yes. If it is there in the dictionary, my WC becomes W. Okay. Please note the difference. If it is there in the dictionary, WC becomes W. If it is not there in the dictionary, then C becomes W. But if it is there in the dictionary, WC becomes W. AB, and then the next character. As you can see, the fifth character to read here is A. I get that A. ABA. Is it there in the dictionary? No, it is not there. Then output the code for W. What is the code for AB? AB, the code is 3. So 3. And then after that, ABA becomes my new entry. This WC, this becomes my new entry. And if it is there, then C is taken as the next W. For the next iteration, the previous C value will be taken as W value. I'm reading the character B, AB. It is there in the dictionary. So WC will become my new W. I'm reading AB A. Yes, it is there in the dictionary. Because it is there, ABA is coming as W. And then after that, I'm reading the last C, which is null. Once I reach null value, then after that, I have here ABA. Yes, it is there in the dictionary, and I output the code by default for W only at the last. So now coming to the algorithm of this. So initialize dictionary with one entry, and then after that, initially W will be empty. I read the next symbol C and form candidate WC. So this and this step is done till here. Now there are two situations. Either it is there in the dictionary or it is not there in the dictionary. If it is there in the dictionary, only reset W to WC. But if it is there in the dictionary, if it is not there in the dictionary, three steps are to be done. First step is code output. This becomes my output string 1, 2, 3, and 5. So output the code, new entry, and then after that my C value becomes new W value. So if it is there in the dictionary, what do I do? If it is not there in the dictionary, there are three steps. And at the end of the output, I output the code for whatever W is holding. So these are the steps that gets followed for LZW. So finally, I'm getting here 1, 2, 3, and 5. So dictionary was completely built from the data itself. Decoding also, no dictionary transmission is required from that same thing, from the same stream that it gets, decoding will be done. Here advantages, it's fully adaptive, no pre-known statistics are needed, no dictionary or table transmitted separately. No And it is fast to decode, it is a good general purpose compressor, and here the dictionary can grow very large. And sometimes if probabilities are well known, then Hoffman and arithmetic are also um, very good techniques.